All right, class, happy Tuesday. Sorry I'm getting this video later than I had planned on to you guys. I was packing. I leave for my parents tomorrow, but I will still be working. So keep sending questions, and I'll be posting the rest of Chapter 11 shortly. So I had promised you guys a video going over some of the Chapter 6 homework problems that I've gotten questions on. Most of them are very similar to the homework problems, but I also did a couple of the homework problems verbatim. I just want to make sure I'm continuing to you guys every resource I could possibly give you in order for us all to succeed in this course. So without further ado, so here's a problem very similar to question 17. So suppose a coin is tossed 6 times. What is the probability that there is at least one head? We're not going to do this problem right here. But I want to know the first one, right? I want to know what's the probability there's at least one head. So I'm flipping a coin 6 times. So the probability of at least one head, that's going to be the probability of one head plus the probability of 2 heads plus the probability of 3 heads plus the probability of 4 heads, plus the probability of 5 heads, right? So that's what's equivalent to the probability of at least one head, okay? Now, how am I supposed to calculate this, right? How big is this sample space? Well, I flip a coin 6 times. So my sample space, I have 2 choices for my first flip, 2 for my second, third, fourth, fifth, sixth. So it's 2 to the 6th, which is 64. So this is the size of my sample space. Now, let's take a look at the probability at least one head. So I either have 1, 2, 3, 4, or 5 heads, okay? I want to know what's the probability of, or 6 heads, right? I could get all 6 heads. I want to know what's the converse of at least one head. Well, the converse, remember if I have a converse, the sum of the event and its converse, denoted with an accent, is 1. So if my event is at least one head, what are my other options? What's the converse of this event? Well, the converse of this event is 0 heads or no heads, okay? That's something that's a lot easier to calculate, right? How many ways could I get no heads if I flip a coin 6 times? There's only one way, okay? So the number of ways to get 0 heads is 1, right? It would be tails, 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 tails. Okay. So if I want to find the probability of at least one head, I can take 1 minus the probability of no heads. Well, there's only one way out of 64 for me to get no heads. So that probability is going to be 63/64. Okay, so this is a problem very similar to problem 17. That's the probability of getting at least one head. The next problem is very similar to problem 41. So let's let A and B be independent events, and the probability that at least one of them occurs is 2/3, and the probability B occurs but A does not occur is just 1/6. And I want to find the probability of A. Okay, so what we're going to do is we're going to take, remembering that these are independent events, so they're mutually exclusive, they do not overlap, they could both occur at the same time, and 2/3 is the probability at least one of them occurs. So I have the probability of A or B. I know that's going to be the probability of A plus the probability of B. So I'm going to take the probability of A or B, that's going to be 2/3. That's going to be the probability of A plus the probability of B, which is 1/6. So I have 2/3. I'm going to subtract 1/6 from both sides. Minus 1/6 equals the probability of A. I got to make these like fractions. That gives me 3/6, which is 1/2. So that's the probability of A. Next, let's do a problem like 42. If A and B are independent events and probability of B is 0.17, what's the probability that exactly one of A or B occurs? So in this case, I don't want both A and B to occur. So I need to calculate the probability of that intersection. Remember, the probability of A intersect B when we're working with independent events is the probability of A times the probability of B. So the probability of that exactly one of them occurs is going to be the probability of A or B is the probability of A plus the probability of B minus 2 times the probability of A intersect B. So I have 0.39 plus 0.17 minus 2 times 0.39 times 0.17. So the probability of A or B equals 0.39 plus 0.17 minus 2 times 0.0063, and that's going to give us 0.4274. We want to round that typically to just 2 decimal places. Anything more is showing off.